Hello once again, and welcome to a more in-depth study of quadratic functions. You guys have studied how to solve quadratic functions, of course, in your past, and you've looked at factoring, quadratic formula, and a technique called completing the square. We're going to look at that idea of completing the square here as we go along in this discussion. But first, let's think about what's hopefully a fairly basic fact about completing the square. If we have look at a quadratic formula, if a is positive, our parabola, that's what we call the graph of a quadratic function, opens up. And if a is negative, this quadratic function opens down. And so I'm going to tell you right now that the standard equation of a parabola with a vertical axis, in other words, one that either opens up or opens down, looks like this. And in fact, we can get any equation we want to look in that form. So let's take a look here. We're going to complete the square. It helps when our leading coefficient is 1. So we've got f of x equals, now I'm going to take my x squared minus 6x, and I'm going to complete the square. So in other words, we're taking half of negative 6, which is negative 3. We're going to square that. That's 9. Now, we're adding 9 here. Here's the plus 11 from the problem. If I've added 9 here, I've got to subtract 9 here to keep my equation balanced. So this is x minus 3 quantity squared plus 2. And as advertised just a minute ago, you'll notice that we've got this in the form f of x equals a times x minus h quantity squared plus k. And you'll notice here, it tells me up here that my vertex is at h, and in this case, my h is going to be 3, and my k is going to be 2. And so we have found the vertex. We've done a little bit more than what the directions called for, but I always like to try to get you a little more bang for your buck when we can. Let's do the same thing here. Now, you're going to notice something here. Notice I've got a negative 2. What I'm going to do is I'm going to factor that negative 2 out of the first two terms. So this is going to be x squared plus 6x. Alright, notice as a check, negative 2x squared minus 12x. Now, I need to complete the square inside of here. Half of 6 is 3. I'm going to square that and get 9. But I want you to notice something. Negative 2 times 9 is negative 18. So in fact, we've put a negative 18 here. That means to keep things balanced, I need a positive 18 out there. And here's a negative 24. Here's a negative 24. So what we're looking at is negative 2 times x plus 3 quantity squared minus 6. Alright, and again, they don't really ask for it, but you'll notice that we have a vertex at negative 3, negative 6. A times x minus h quantity squared plus k. So there we go, and if you would be so kind for class discussion, please prepare problems 7 and 10 from the problem set 5, 8, 9, and 11 for homework. Now, you say, well, this is all well and good, or maybe it's well and good. I mean, after all, most of us don't really care to complete the square unless we just absolutely have to. But why would this work? Why would it be that HK would be our vertex? Well, let's consider the standard form of a parabola here. And so what I'm going to do, this is y equal, I'm going to factor the a out. Here's x squared. Now if I factor the a out, I've got to write this as b over a times x, noting that a times b over a is b. Alright, and then I'm going to complete the square. Now let's write this out so that we know what's going on. Half of b over a, square that. Alright, and then don't forget I've got the plus c hanging around out here. Now, what I've added here, Okay, I'm going to need to subtract over here. So what I've done, I've got a over 1 times b over 2a squared. So let's take a look at what we've got here. For just a minute, I'm going to leave this a times the quantity x squared plus b over a x plus b squared over 4a squared. Alright, here we go. Plus c minus ab squared over 4a squared. Or in other words, let's clean this up now a bit. This is a. Remember, I've created a perfect square trinomial here. Perfect square trinomial. So we know square root, center sign, square root. Quantity squared. And here, I'm going to need this simplified a little bit. And let me just write this as c minus b squared over 4a. Right? Either way we cut it, we're looking at a times x minus h, or we could write it as x plus a negative h, quantity squared plus k. And so the x coordinate of my vertex is the opposite here, negative b over 2a. Alright, noting, thinking bubble, time. Negative h equals b over 2a. So h equals negative b over 2a. And noting here that another way I could look at this, if we solve this using the quadratic formula, alright, we know my solutions are at negative b over 2a plus the square root of b squared minus 4ac all over 2a, and x equal negative b over 2a minus the square root of b squared minus 4ac all over 2a. Now if we add those two x-intercepts together, what we get is negative 2b over 2a. If you think about any parabola, your vertex is going to appear exactly halfway between your two x-intercepts, and so 1/2 of negative 2b over 2a is negative b over 2a. So there's another way that we can go about showing that the x-coordinate of my vertex can be spelled out if we have this simply by looking at negative b over 2a. And then the y-coordinate of the vertex, of course, we can find rather simply if we evaluate, the function f of x equal y, f of negative b over 2a. Okay? So that's why we're able to so slickly and so quickly go about finding the vertex. So if we look here at example 3, which is problem 18 from the set, and you'll notice, guys, that problem 18, straight from the homework as we're used to, I need to use the quadratic formula here. It asked me to find the zeros. So x equals negative 4 plus or minus the square root of 4 squared minus 4 times a, which is negative 4, times c, which is negative 1, all over 2 times negative 4. So we've got negative 4 plus or minus the square root of 16 minus 16 all over negative 8. Well, isn't this convenient? So we've got negative 4 plus or minus the square root of 0 over negative 8, which turns out to be 1/2. So that is my solution. And that also means that I've got an x-intercept at 1/2, 0. Alright, now they want me to find the maximum or minimum value of the function. Now, max, min, which is it? Well, notice a is less than 0, so the graph opens down, and we're going to have a max. The max happens at the vertex, negative b over 2a, negative 4 over 2 times negative 4, which is 1/2. And f of 1/2, we've got negative 4 times 1/2 squared plus 4 over 1 times 1/2 minus 1, so we simplify this and we get 0. Well, that was kind of nice. So we have a maximum value of 0. Okay. And that actually, not only is our x-intercept and our vertex, happens to be where our maximum occurs. And so we can sketch this in, and that's a really lousy coordinate axis there. So let's try this one more time. There's 1. We know we're going to open down, and again, if I don't ask for more specifics, this will be just fine. So there's my graph. Alright, and so now if you would, for class discussion, take a look at 16 and 20. And then for homework, please look at 13, 14, 17, 19, and 21. Now we've got a graph of a parabola here, and I would encourage you to note that the vertex, HK, is the point -1, -2. And then also please note that on this I have the point given to me 2, 3. Now let's take a look at what we know. Y equals A times x minus h quantity squared plus k. Well, isn't this convenient? Y we know is 3. We don't know A, but that's okay. We know x, that's 2. H, that's -1. And k is -2. So we've got 3 equal A. 2 minus the -1 is 3. We square that, we get 9 minus 2. We need to solve for A. I'll make note of that. Solve for A. So we add 2 to both sides. 5 equals 9A. A equals 5/9. And so here's my equation. Y equals 5/9. X minus the x coordinate here. X minus -1, quantity squared. And then k is -2. And so let's clean this up just a bit. Y equals 5/9 x plus 1, quantity squared, minus 2. And if you have questions, certainly feel free to bring those with you to class. And now we're going to do another problem, very, very similar. The only difference here is that we're not given a graph, but that's okay. That's okay. We don't need to have a graph. What we have here, get my pen turned back on, what we have is the fact that HK equals 4, -7, and we've got an XY point of -4, 0, because I'm told that I've got an x-intercept of -4, 0. So we've got here again, y equal A times x minus h quantity squared plus k. I know what y is. Y is 0. A, well, that's what we're looking for. X minus h, what is h? That's 4 quantity squared. And k, well, that's -7. Alright, so, and you know what? I forgot to fill in my x coordinate. My apologies. In fact, I need to put that in here. X coordinate is -4 minus 4. So let's see what we've got here. 0 equals -4 minus 4 is -8. Square that, we get 64 minus 7. A equals 7 over 64. And so when we get ready to write our equation here, y equals 7 over 64 times x minus 4 quantity squared minus 7. So those two examples I just worked, very, very similar. Just one gives us the points on the graph, one writes them in a sentence for us. We've spoken briefly already about the fact that if A opens down, alright, so if A is less than 0, then Y opens down, thus A max. And if A is greater than 0, Y opens up, thus a min. Alright, so opens down, there's my max. Opens up, there's my min. And so the results that we've just looked at here in this session, different forms that these parabolas can take, and you can see the benefits of each. You can see the vertex here, how we can go about finding it. We can take the average of the x-intercepts, or we can use negative b over 2a. And then for the x-intercepts, we've got some options here. We can use the quadratic formula, which they just talk about proving. We've kind of already been through that a little bit, and if we're given x1 and x2, there's my x-intercepts. Or I can use h plus or minus the square root of negative k over a, and you can consult your book for that. Let's take a look here at example 6. We're told the number of miles m a certain automobile can travel on 1 gallon of gas at a speed of v miles per hour is given by this function. We need to find the most economical speed for the trip. Well, notice here that a is less than 0, and so that means our parabola is going to open down. The vertex is where the most economical speed would be, so we're going to investigate negative b over 2a. Negative b is negative 5 halves over 2 times negative 1 over 30. And I'll let you guys go through the details, but this turns out to be 37.5 miles per hour. And then, to actually find the largest value of m, we are going to simply say that m is equal to negative 1/30 times 37.5 quantity squared plus 5 halves times 37.5, and I'll let you guys go through the details, but this turns out to be 46.875 miles. Alright, so we're just finding the vertex there, and please work 39 for homework. Now let's take a look at another example here. An object is projected vertically upward with an initial velocity of v0 feet per second. Its distance s of t in feet above the ground after t seconds is given by this function. If the initial velocity is 96 feet per second, when will the object reach 80 feet? Well, so what we want to do, we are told the initial velocity here, so this is going to give me negative 16 t squared plus 96 t and a height of 80. Alright, so here we go, negative 16 t squared plus 96 t minus 80 equals 0. It turns out that we can divide everywhere by 4, so negative 4 t squared plus 24t minus 20 equals 0. And conveniently we can take out another 4. So and let's take a negative 4 out this time, shall we? T squared minus 6t plus 5 equals 0. T minus 1, t minus 5, this equals 0. So we've got t equal 1 and t equal 5, and so we need to know when the ball will be 80 feet above the ground. At 1 second and at 5 seconds, the ball will be 80 feet in the air, or the object, I should say. Object is 80 feet in the air. And then for part B, it wants to know when will the object reach the ground. Well, this time we're going to set, for part B, we're going to set negative 16 t squared plus 96t. We're going to set that equal to 0. And I can factor out a negative 16t here. That's going to leave me with t minus 6. That equals 0, so t equals 0, t equals 6. And of course we know the ball or the object is on the ground before it's been released, so it'll reach the ground after 6 seconds. The ball hits the ground. Let's take a look now at example 8, which is very, very similar to problems 45 and 46 in your textbook that I'm going to ask you to work for homework. What we've got is a farmer going to enclose a rectangular region bordering a barn with fencing. So it says, suppose X represents the length of each of the 3 parallel sides of fencing. So here's my barn, lovely barn, 3 parallel sides, all of length X, and I'll call the side parallel to the barn Y, but we might notice that there are 600 feet of fencing available, so we've got 600 minus 3X, and that'll be the length of this side. Now, we want to know what is the length of the remaining piece of fencing in terms of X. Well, I think we just took care of that, right? We've got 600 feet. We take out this side, we take out this middle here, and we take out this side, and we've got 600 minus 3x. Now B wants to know, determine a function A that will represent the total area of the enclosed region. Well, area in terms of x, we know length times width, so we're looking at x times 600 minus 3x, or negative 3x squared plus 600x. So there's my area. And now we want to know what dimensions for the total enclosed region would give us an area of 22,500 square feet. So we'll set that area function equal to 22,500. Alright, so we have 3x squared minus 600x plus 22,500. That equals 0. And it turns out if we divide everywhere by negative 3, we get, actually, you know what, let's divide by positive 3 instead. X squared minus 200x, and then 22,500 divided by 3 is 7,500 equals 0. Alright, and this will factor then into x minus 150 and x minus 50. And so what dimensions for the total enclosed area would give us this? Well, let's see here. If we have x equal 50, now notice that if we have x equal 150, if each of these are 150, okay, then we'd have 150 feet left. So either way we cut it, x equal 50 and x equal 150, those would be the dimensions that would give us 22,500 square feet. So 50 feet by 150 feet produces an area of 22,500 square feet. Okay. And then D wants to know what dimensions will maximize the area that can be enclosed, and what is that maximum area? Well, again, we're looking for the vertex here. If we're looking for a maximum, let's go get our negative b over 2a. Alright, so negative b over 2a equals negative 600 over 2 times negative 3, which is 100, and a of 100, well, that's negative 3 times 100 squared plus 600 times 100, and so that maximum area is going to be 30,000 square feet. And we could get that by 100 by 300. Fence in an area 100 feet by 300 feet. Alright, and then one last problem here to look at. Another piecewise defined function. Imagine that. Good thing we studied that in our last lesson, huh? A wholesaler sells running shoes at $20 per pair if less than 50 pairs are ordered. Now, if 50 pairs or more are ordered, up to 600, the price per pair is reduced by 2 cents times the number ordered. What size order will produce the maximum amount of money for the wholesaler? Well, the first thing we want to do here is define the variable. What size order? That's going to be my variable. Let X represent the size of the order. Size of the order. Alright, and so we're going for revenue here. Revenue, of course, is defined in terms of the amount of shoes we sell. So we're bringing in $20 a pair if X is between 0 and 50. Actually, just less than 50. But if we order 50 or more pairs, we are going to take 2 pennies. Woo! 2 pennies off for every pair of shoes that we go over 50 up to 600. So we're looking here at 50 less than or equal to X less than or equal to 600. Okay. Now we take a look here. We can simplify this just a little bit if we wanted to. We know that though with the I'm going to make a little adjustment there. We're going to say that wholesaler sells running shoes at $20 a pair if less than 51 pairs of shoes are ordered, and that way I think that'll make our numbers work a little nicer. We can go less than or equal to 50 there, and we can say 51 to 600 here. Alright, so there is my revenue function, and now we're going to figure out here for the first part. It's linear, so the first part will be maximized. 20x is maximized at x equal 50. So we're looking at $1,000 there, 20 times 50. And we know the second part we recognize here is going to be a parabola. This is negative 0.02 x squared plus 20x, and of course we're going to get a maximum there. We're going to get a maximum there for the second part. Negative 0.02 x squared plus 20x is maximized at x equal negative b, so negative 20 over 2 times negative 0.02, and let's see, that gives me $500. That gives me 500 rather. And so then my revenue at 500, R of 500, well, that's just going to be 20 times 500 minus 0.02 times 500 squared. And this turns out to be $5,000. So ordering 500 pairs of shoes will maximize revenue and it will be $5,000. And so please take a look at problem 56 for class discussion, working problems 53 through 55 for homework, and bring any questions with you to class as always.